Hey class, we're going to continue on with Chapter 3, Scientific Measurement. So far we have covered lessons that talked about the SI system, we talked about metric prefixes, we talked about how to convert between the metric prefixes, temperature, how to convert between different types of temperature, but we're going to end on talking about density. And density should sound familiar because we talked about it as being a derived unit in our SI system. Remember, a derived unit means that it comes from one of the base units. If we actually look at density, it is actually a relationship between the object's mass, which is actually a base unit with the unit kilograms, and its volume, which is another type of derived unit, and its unit is meters cubed. And this relationship of the object's mass to its volume will actually tell me, will something float or sink? Density is then defined as the ratio, and whenever you think of ratio, we should think of division. So in other words, it is the division of the mass of an object to its volume. I'm going to go ahead and star this because this is an equation you are going to use on your test, and you're going to use it on a worksheet coming up in class. Density is mass divided by volume. And what that means is mass can be a lot of different units. It can be grams, it can be kilograms, it can be ounces, it can be pounds, but typically grams and kilograms are the units that we use. Volume can have a lot of different units. Liters we learned was a non-SI unit. Milliliters, we have centimeters cubed, and then we can also have meters cubed. Now what about density's unit? Now density's unit can be different, as long as there's a unit for mass on top and a unit for volume on bottom. So for example, it can be grams per liter, it can be grams per milliliter, it can be grams per meters cubed, it can even be kilograms per meters cubed, as long as there's a unit for mass divided by a unit for volume. For example, if you measured a mass in grams and you measured the volume in cubic centimeters, your unit for density would then be grams divided by cubic centimeters. However, our SI unit, which is our unit that we most often use, is going to be kilograms per meters cubed. Here is an image of 4 substances: lithium, water, aluminum, and lead. If I gave you the mass of each and say, let's say all of them are 10 grams, when I measure that amount of mass, you're going to measure its volume. So there's 19 centimeters cubed for lithium, 10 for water, 3.7 for aluminum, and 0.88 for lead. You would take those masses and divide by the volumes and get these following densities. Please note that this will actually allow us to see if things will float or sink. Typically, if we see if things float or sink, we're going to put them in water, and it's standard for us to know that water is 1 gram per centimeters cubed. Anything less than 1 is typically going to float in water. So for example, lithium, if you put it in water, it will float. Anything bigger than 1 is generally going to sink. So if I put aluminum in water or lead in water, it is going to sink. Now our key question is, what determines the density of a substance? And one thing that we have to pull from Chapter 2 is that density is actually an intensive property. Now intensive, if we remember from Chapter 2, depends on the type of substance, not the amount. So all that means is that we depend on the composition of that substance. We don't care the size of it. For example, if I go back to the last slide, lithium, we measured out 10 grams here, but we could have had 20 grams of lithium, we could have had 50 grams of lithium. That's actually going to change the volume, and no matter what, it's going to come out to be the same density. Lithium's always going to be 0.53 density. It will not change. Water will always be 1. Aluminum will always be 2.7. So it depends on the type of substance, not the amount. Here we have an image of a couple different substances, and we're going to note that they are floating on top of each other. For example, we got corn oil on the very top, water underneath it, corn syrup further down. And what this image shows is that the density of corn oil has to be less than the density of water for it to float on top. Corn syrup has to have a greater density or be more dense than water in order to sink below it. Here are some densities of common materials that you guys can see. So for example, gold actually has a pretty high density. Mercury actually has a pretty high density, but since gold is greater than mercury, if you put those two together, gold would sink. Aluminum is about 2.7, sugar is about 1.59. When you get over here to gases, sometimes they're lighter. So for example, air is actually about 1.2, but methane is 0.665. So what happens to the density of a substance as the temperature increases? One thing to note is that the volume of most substances typically are going to increase as the temperature increases. And that's just a gas law that we hit on when you guys were freshmen. But while the volume increases, typically our mass remains the same. Now, since density is the ratio of an object's mass to its volume, the density actually generally decreases as temperature increases. So all that means is this is an inverse relationship. Again, if the temp goes up, the density goes down. The only exception for this is water. Water is very, very weird. In fact, as the temp goes down, it actually becomes more buoyant. That's why ice floats. Now, I did say you were going to have to use that equation, and here we're going to go through several problems of how to calculate density. Remember, density equals mass divided by volume. When you do these problems, we need to actually read through and see what it gives us. It says a copper penny has a mass of 3.1 grams. So here we know that mass is 3.1 grams. It says it has a volume of 0.35 centimeters cubed, so volume of 0.35 centimeters cubed, and it's asking us to find our density. So we don't know that, so I'm going to put an X. Once you read the problem and figure out all of the things that you're using in the problem, we're going to plug them into this equation. Notice that density, we have to plug in X. We have the equal sign. For mass, we said that it was 3.1. And then for volume, we said it was 0.35. Since X is already by itself, we can actually go ahead and solve this and take 3.1 divided by 0.35, and you're actually going to get the answer of about 8.857 and some other numbers behind it. Now, if you gave me this answer, I would say it's incorrect because you don't have a unit. We talked about how measurements have to have a number and a unit. So we got to look at this. Our mass was grams, our volume was centimeters cubed. So when you write your unit for density, we're going to see that it is grams divided by centimeters cubed. Again, your unit is going to come from the units you use in the problem. What if I didn't ask for density? What if I wanted you to calculate mass? You're going to follow similar steps. We are still going to use the equation that density equals mass divided by volume. We have to read the problem and see what we're given and what we need to solve for. It says an object has a density of 8.47 grams per centimeter cubed. So here I know my density. It says if the volume of the object was 0.541 centimeters cubed, so you're going to write that under the volume, and then it's asking what is the mass, so I'm going to plug in X for that. We're going to take all these numbers that we gather and then plug them into their designated spot. So 8.47 for density. Mass, we don't know that, so we're going to plug in X, and then volume, we plug in 0.541. Now, I always tell people when you have a setup like this is to actually just make them equivalent to each other. I always tell people to put this over 1, and then we use the term cross, multiply, and divide. So here 1 times X gives me X. This is going to equal 8.47 times 0.541, so 8.47 times 0.541. And you should get about 4.58 with some numbers. Again, x is by itself, and here we have our answer. However, I would mark you off because again, we have no unit. Since it's asking for mass, we're going to look at my densities unit. And notice that for density, we have it grams per centimeter cubed. Remember, our mass is our top part. So here, our mass was actually measured in grams. And then our last one is asking us to calculate volume from density. Again, our equation is density equals mass divided by volume. And we're going to see if we can find these in our problem. It says an object has a density of 6.88 grams per centimeter cubed. So 6.88. It says a mass was 15.3. And then it's asking what is the volume of the object, so that we don't know. Again, we're going to take these values and plug it into our equation. We know our density is 6.88. We know our mass is 15.3. We know our volume is x. Just like the last problem, we want to set this up where we can cross multiply and divide. So we're going to put this over under 1. We're going to cross multiply. So 15.3 is going to be 15.3 equals, and then x times 6.88, so we get it 6.88x. Now x is not by itself, so we call this cross multiply, and then we got to divide to get x by itself. So we're going to divide both sides by that 6.88, and we're going to find out that 15.3 divided by 6.88 is actually going to be about 2.22. Just like any other problem, I'm going to ask for a unit, and it's asking for volume. Volume comes from our density unit. So notice our density unit is grams per centimeter cubed. Well, that grams is mass. So here, our volume unit is centimeters cubed. And that's the end of today's lesson. If you guys have any questions, please make sure you ask. And I hope you guys have a great day. Thank you.